Have you ever looked up at the night sky and wondered what else is out there, drifting in the vast, dark ocean of space? We're familiar with the planets in our own solar system, dutifully orbiting our sun. But what if I told you there are cosmic wanderers, planets without a star, roaming the galaxy all by themselves? These are called rogue planets, and the idea of one entering our solar system is both fascinating and, let's be honest, a little terrifying. So, what exactly is a rogue planet? Think of it as a celestial orphan. Most planets are born from the same swirling disk of gas and dust that forms their parent star. But sometimes, a planet can be violently ejected from its home system through gravitational battles with other, larger planets. Imagine a cosmic game of billiards where a planet gets knocked right out of its pocket. Others might form in isolation, condensing from a cloud of gas and dust that just wasn't big enough to ignite into a star. These are the loners of the galaxy, shrouded in perpetual darkness, unbound by the gravity of any sun. Scientists believe there could be billions, maybe even trillions, of these rogue planets in the Milky Way alone. That's potentially more rogue planets than stars. Most of them are impossible to see directly because they don't emit their own light, and there's no nearby star to illuminate them. We can only detect them through clever methods like gravitational microlensing, where a rogue planet passes in front of a distant star, and its gravity briefly bends and magnifies the star's light, creating a telltale flicker. It's like finding a ghost by the shadow it casts. Now for the big question. What would happen if one of these dark wanderers paid our solar system a visit? The outcome would depend entirely on its size and its trajectory. Let's start with a less dramatic, but still significant scenario. Imagine a Mars-sized rogue planet passing through the outer reaches of our solar system, say, out beyond the orbit of Neptune. Even at that immense distance, its gravitational pull could stir things up. It could disrupt the Kuiper Belt, a vast ring of icy bodies, and the Oort cloud, an even more distant sphere of comets surrounding us. This gravitational nudge could send a shower of comets and asteroids hurtling towards the inner solar system. And that, of course, would dramatically increase the chances of a major impact event on Earth. We'd see a sky filled with more shooting stars than ever before. But some of those shooting stars might be city-sized rocks on a collision course with our planet. It would be a cosmic domino effect, started by a visitor we might not even see. But what if the rogue planet came closer? Let's say a gas giant, a planet the size of Jupiter or even larger, passed through the heart of our solar system. This is where things get truly chaotic. The gravitational balance of our solar system is a delicate dance that has been refined over billions of years. A massive intruder would be like a wrecking ball crashing the party. As the rogue planet approached, its immense gravity would start to pull on the orbits of our own planets. The beautiful, nearly circular paths of planets, like Earth and Mars, could be stretched into highly elliptical, or oval-shaped orbits. This would cause extreme climate swings on Earth. During the part of our new orbit that took us closer to the Sun, temperatures would soar, potentially boiling our oceans. When we swung far away from the Sun, we'd be plunged into a deep global ice age. Life as we know it would struggle to survive such violent environmental shifts. The orbits of other planets would be thrown into disarray too. Venus might be pushed closer to the Sun. Mercury could be swallowed by it entirely. The asteroid belt between Mars and Jupiter could be scattered, sending a hailstorm of rocks in all directions. Our moon, which stabilizes Earth's tilt and creates our tides, could be pulled away from us, leaving our planet wobbling on its axis like a spinning top. The consequences would be catastrophic. And now for the ultimate nightmare scenario, a direct collision. If a rogue planet were on a direct impact course with Earth, well, that would be game over. A planet-sized impact would be an extinction event on a scale we can barely comprehend. The energy released would be millions of times greater than all the nuclear weapons on Earth combined. The impact would vaporize the planet's crust, boil the oceans, and eject a massive cloud of debris into space, potentially forming a new ring around the sun. Our planet would be sterilized, reset to a molten ball of rock. But before you start building a bunker, let's put this all into perspective. The chances of a rogue planet actually entering our solar system are incredibly small. Space is, to put it mildly, vast. The distances between stars are enormous. While there may be billions of rogue planets out there, the odds of one happening to wander into our tiny corner of the galaxy are astronomically low. It's like trying to hit a specific grain of sand on a beach by throwing another grain of sand from a mile away. So, while the rogue planet theory presents a mind-bending what-if scenario, it's not something that should keep you up at night. Instead, it serves as a powerful reminder of how dynamic and sometimes violent the universe can be. It highlights the intricate, delicate balance that makes life on Earth possible. Our solar system is our safe harbor in the vast cosmic ocean. The study of rogue planets is still in its infancy. With new telescopes like the James Webb Space Telescope and the upcoming Nancy Grace Roman Space Telescope, we're on the cusp of discovering more of these cosmic nomads. Learning about them won't just satisfy our curiosity. It will help us better understand how planetary systems form, evolve, and sometimes fall apart. It is a fascinating frontier of astronomy that reminds us there are still so many secrets waiting to be discovered in the dark. So the next time you look at the stars, remember the hidden wanderers, the rogue planets drifting silently between them. They are a testament to the wild, untamed nature of our galaxy. Have you ever wondered what would happen if the Earth suddenly decided to change its path around the sun? It sounds like science fiction, right? But what if it wasn't? What if our planet's orbit, the very thing that gives us our predictable seasons and stable climate, suddenly shifted? Welcome to the chilling thought experiment we call gravitational whiplash. Imagine waking up one morning and something just feels off. The sun seems a little too bright, or maybe it's dimmer than usual. Days feel longer or shorter. At first, you might just brush it off. But then the news starts pouring in. Astronomers are in a panic. The Earth is no longer following its familiar elliptical path. It's been nudged. Let's break down what Earth's orbit actually does for us. It's not a perfect circle. When it's tilted away, the seasons flip. Our orbit keeps this celestial dance incredibly regular. Scenario 1. Our orbit becomes much more elliptical, more like a stretched-out oval. Forget the gentle transition of spring and autumn. We'd be catapulted into extreme seasons. We're talking about global temperatures soaring. Ice caps in Greenland and Antarctica would melt at an unprecedented rate. Sea levels would rise catastrophically, not over centuries, but over years or even months. Coastal cities like Miami, Amsterdam, and Shanghai would be submerged, creating hundreds of millions of climate refugees. Agriculture would collapse. The intense heat would scorch crops, leading to worldwide famine. Deserts would expand, and life-giving rainforests like the Amazon could turn into arid wastelands. Then, as we rocket away to the farthest point of our new orbit, the aphelion, the planet would plunge into a deep freeze. A brutal, extended winter would grip the globe. Temperatures would plummet far below anything we experience now. Oceans could begin to freeze over, creating vast sheets of ice that reflect sunlight back into space, making the planet even colder. This is a feedback loop known as the ice albedo effect, and it could potentially trigger a new ice age. Life would be a desperate struggle for survival between fire and ice. What about our day-to-day life? The length of a day, about 24 hours, is determined by Earth's spin on its axis. A more elliptical orbit would mean a longer year. Our calendars would be useless. The very concept of a year would need to be redefined. Let's say our 23.5-degree tilt was suddenly increased to, say, 45 degrees. The seasons would become incredibly extreme. Summers in the northern hemisphere would be scorching hot, with the sun almost directly overhead for months. Meanwhile, winters would be plunged into polar darkness and unimaginable cold. The temperature difference between summer and winter in places like Europe or North America would be life-threatening. The lack of seasonal change would disrupt ecosystems, plant life, and the migratory patterns of countless species. The world's weather engine, driven by seasonal temperature differences, would grind to a halt, leading to unpredictable and stagnant weather patterns. In either of these scenarios, the gravitational whiplash would have a profound effect on everything we know. Imagine monster tsunamis without any warning, driven by a wobbling moon. GPS satellites, which need to account for Earth's gravity with incredible precision, would become useless. Navigation, communication, and even financial markets would be thrown into chaos. Our entire technological infrastructure is built on the assumption of a stable Earth. Our planet exists in a delicate cosmic balance, a Goldilocks zone where everything is just right for life to flourish. We live on a world with a stable orbit, a gentle tilt, and a large moon that stabilizes our spin. It's a cosmic lottery we've won, and it's what makes our home so special. While a sudden shift in our orbit is extremely unlikely, it makes you appreciate the intricate and fragile systems that support us. The forces that govern the cosmos are immense and powerful, and we are just along for the ride on this beautiful blue marble. It's a humbling thought, isn't it? Our world is a precious and perhaps unique oasis in the vastness of space. Ever wondered what would happen if the world's food supply suddenly just stopped? No more overflowing grocery stores. No more midnight takeout. It sounds like the plot of a disaster movie, but a recent study published in the journal Nature Food explored this exact scenario, and the results are pretty eye-opening. They looked at what would happen if the sun were suddenly blocked, say, by a supervolcano, nuclear winter, or an asteroid strike. It's a dark thought, but one that forces us to ask a crucial question. Who would be best prepared to survive? The researchers modeled a soot catastrophe where sunlight would be drastically reduced, plunging global temperatures and devastating agriculture as we know it. In this grim future, where would humanity's best hope lie? You might think of countries with massive stockpiles or advanced technology, but the study points to a surprising group of island nations. Let's look at the top contenders: Australia and New Zealand. Why them? Well, It's a combination of factors. First, their location. Being islands, they're naturally isolated, making them easier to defend and less susceptible to the chaos that would likely engulf larger, interconnected continents. They can control their borders and protect their resources more effectively. But it's not just about geography. Australia came out on top as the ultimate lifeboat. It has a massive agricultural capacity, enough to potentially feed not just its own population, but tens of millions more. Think about it. Vast farmlands, a relatively low population density, and a robust food production system already in place. It's like having a giant, pre-stocked pantry. Even in a worst-case scenario where they have to feed over 100 million people, including refugees, Australia's food surplus gives it a massive head start. New Zealand isn't far behind. Like Australia, it's an island nation with a strong agricultural base. Plus, its reliance on geothermal and hydroelectric power makes its energy grid more resilient in a world where traditional fuel sources might become scarce. It's got that self-sufficient vibe down. The study also highlighted other island nations like Iceland, the Solomon Islands, and Vanuatu as having good potential to produce enough food to ride out a catastrophe, thanks to their locations and existing food systems. Now, what about the rest of the world? The picture is much grimmer for countries in the Northern Hemisphere, including major powers like the UK, the US, and China. Why? Because their current food systems are incredibly fragile and globalized. They rely heavily on imports and complex supply chains that would shatter in a global crisis. Take the UK, for example. It's densely populated and imports about half of its food. In a sunlight blocking event, its own agricultural output would plummet. The country would likely face widespread famine within months. It is a stark reminder of how dependent we have become on a global system that works fine in peacetime, but is incredibly vulnerable to shocks. The study predicted that these nations would probably collapse. The United States and China, despite their vast size and resources, would face similar challenges. They'd have to feed enormous populations with drastically reduced crop yields. The social and political chaos would be unimaginable. These countries would become what the study calls failed states, unable to maintain order or provide for their citizens. So, what's the secret sauce for survival? It boils down to a few key things. First, food self-sufficiency. Can a nation feed its own people without relying on anyone else? This is the number one factor. Second, energy independence. Can it power itself when global energy supplies are cut off? Third, manufacturing capability. Can it produce the essential tools and goods needed to keep society functioning? The study essentially created a survivability index for 177 countries, and the results draw a new map of the world. It's not a map of economic power or military might, but a map of resilience. On this map, Australia and New Zealand are the superpowers. They have the land, the resources, and the isolation to potentially weather the storm. But here is a critical point the researchers make. Even these lifeboat nations are unguaranteed to make it. Survival isn't just about having food. It's about cooperation. The study warns that without careful planning and a spirit of collaboration, even the best prepared nations could fall apart from the inside. Imagine millions of desperate people trying to get to Australia. The social pressure would be immense. The lucky few would need to manage their resources wisely and, more importantly, maintain social cohesion. The instinct might be to close the borders and hoard everything, but the study suggests that a degree of cooperation might be the key to long-term survival. This research isn't meant to be a doomsday prophecy. It's a wake-up call. It highlights the hidden vulnerabilities in our modern, interconnected world. We've built a global food system that is incredibly efficient in good times, but dangerously brittle. A single, catastrophic event could bring the whole thing crashing down. So, what can we do? The study's authors urge governments to take these threats seriously. They recommend creating national strategies for resilience. This includes things like boosting domestic food production, investing in resilient technologies like greenhouses that don't rely on sunlight, and creating detailed plans for how to respond to a global catastrophe. They even suggest a preparedness test, like growing a portion of a nation as food with alternative methods to see if it is even possible. It's about shifting our focus from pure efficiency to resilience. Instead of just asking how we can produce food as cheaply as possible, we need to ask how we can produce it reliably, even in the face of disaster. This could mean more local farming, more diverse crops, and more research into alternative food sources, like protein from bacteria or seaweed, which are less dependent on sunlight. This isn't just a job for governments either. It's a conversation we all need to have. We need to think about where our food comes from and what we would do if that supply chain were broken. On a community level, things like local gardens, seed banks, and skill sharing can all build resilience from the ground up. Ultimately, this new map of humanity is a thought experiment, but one with very real implications. It shows us that in the face of a true global crisis, the old hierarchies of power and wealth might become meaningless. The ultimate resource wouldn't be money or weapons, but a stable food supply and a cohesive society. It forces us to look at the world differently and to appreciate the fragile systems that sustain us every single day. The chances of a supervolcano or asteroid strike are low, but not zero. And being prepared isn't about being paranoid. It's about being smart. Thanks so much for watching. What do you think? Which countries do you believe are best prepared for a global crisis? Let me know your thoughts in the comments below. And if you found this interesting, don't forget to like this video and subscribe for more deep dives into the science that is shaping our world.